Hello everyone, welcome to this lecture 2 of our course Metrics and Analytics of Marketing. This week we are discussing about various metrics associated with pricing strategy. In the last class we discussed about price premium and the relative metrics. In today's session we are going to discuss some important aspects related to pricing, and we will cover the metrics such as reservation price, percent good value and linear demand. By reservation price, basically we refer to the maximum price that a customer is ready to pay for a product. Anything above that price, the customer is not going to purchase the product. Percent good value is basically the percentage of customers who are considering that the price that is being paid for the product is valuable for them. Means their reservation price is slightly higher than the price set. Then by linear demand, we consider that demand of a product is a linear function of the price, having a constant slope and probably a intercept. So let's dive more into the various metrics associated with this pricing strategy. Let's start our discussions with the topic of reservation price. What do we mean by reservation price? It denotes the price above which a customer will not buy a product, also known as the maximum willingness to pay. Anything above that particular price, the customer is not going to pay for it, right. The reservation price is the value a customer places on a product. It constitutes an individual's maximum willingness to pay for that product. Remember that customer will probably be happy to pay a lower price than the reservation price. Basically, reservation price is the threshold value, the maximum value that the customer is going to pay for that product. Normally, for most of the customer, the price that the customers are paying is always lesser than the reservation price. So, we will try to look into how the right price of a product is being set after understanding the reservation price of each of the individuals. Another concept related to reservation price, which is very closely related to reservation price, but it is slightly different from it as far the construct of the matrix is concerned. That is the percent good value. Percent good value is the proportion of customers who perceive a product to represent a good value. That is, to carry a selling price at or below their reservation price. Let us say my reservation price is 100 rupees. I am going to pay 100 rupees, maximum I am going to pay 100 rupees for this product. Let us say if the product is priced at 70 rupees, yes, I am considered as a part of the people for whom the good value is, the product is of good value. Percent good value represents the proportion of customers who believe that the product is a good value in terms of price at that specific set price. So, these are the two important and related metrics associated with pricing. Now, let us look at the purpose of the reservation price and the percent good value. Reservation price, it provides a basis for estimating the product's demand function, especially in situations where other data are not available. We know that there is a demand curve, there is something called elasticity of demand that we will look in subsequent classes, but in absence of those data, how do I optimize the price to maximize the profitability? That is where the reservation price comes into picture. They also offer the marketers insight into pricing latitude. Second thing is that when it is not possible or convenient to ask the customers about their reservation prices, then another metric, which is the percent good value, can provide a substitute for that metric. They are related to each other. So, in a way we can use one metric as a proxy for another, but with a detailed analysis. Both reservation price and percent good value are useful metrics in marketers' evaluation of pricing and customer value, right. What price needs to be set by the marketer. So, what is the main intention of the marketer? It is to optimize the profitability of the organization. In a way, we will try to calculate what is the cost of production, what is the variable cost of production, then we will try to find out what will be the contribution margin at different price level, and at different price level what will be their quantity demanded, and whichever price point will give the highest level of profit, that is considered as the optimum price. And the metrics such as reservation price and percent good value helps us evaluating this optimum value. Now, let's discuss about the techniques of reservation price metric. Remember that asking each of the individual about what is your reservation price is a difficult task. It is not a convenient question to be asked to the individuals. Therefore, two techniques that are frequently used to gain insight into the reservation price, one is the second price auction and second one is the conjoint analysis that we have already discussed in some of our previous sessions. So, let's discuss about this second price auction method. In a second price auction, the highest bidder wins, but the pays only the second highest bid amount. Basically, you can just think about a hypothetical situation where you will place a price for a product and there will be multiple individuals who will place their price for that particular product. So, let us say if you are the highest bidder, then in that case you win the auction, but you will be ending up paying the second highest price, that is said, I mean the price set by the second highest bidder, right. So, in a way you are getting a discount. Auction theory suggests that when the bidding on items of known value in such auctions, individuals have an incentive to bid their reservation prices. As you are paying the second highest amount, that is why you are ready to put your exact reservation price. Certain survey techniques have been designed to mimic this process, mimicking the process of you bid for the highest amount that you are willing to pay, but you end up paying the second highest, the amount that is set by the second highest bidder. So, one of these techniques, customers are asked to name their prices for an item with the understanding that these prices will then be subjected to a lottery. If the price drawn in the lottery is less than the price that is named, then the respondent gain an opportunity to purchase the item in question at the drawn price. Basically, whatever price you are setting, whatever your price you are bidding, ultimately you are getting to purchase the product at that price or a price below that. So, this is how we can try to understand what is the reservation price for each of these individual. Then second one is, second method to find out the reservation price can be of conjoint analysis. What is conjoint analysis? Basically, it is all about evaluation of customers' preferences for each of these attribute and attribute levels. If we consider price as an attribute of the product, then in that case the utilities that will be derived by the customer at different price level will be different. For instance, if I am paying 5,000 rupees in a hotel, my utility will be different from another situation where I am paying just 3,000 rupees in the same hotel. Probably I will derive more utility for in case I am paying just 3,000 rupees for staying in the same hotel. So, this can be covered, this can be understood with conjoint analysis. Marketers gain insight into the customer's perceptions regarding the value of any set of attributes. In this case, the attribute is price through the trade-offs that they are willing to make, right. So, let us say if 5,000 rupees I get a bigger room and in 3,000 rupees I get a slightly smaller room, then also I might ending up paying the 3,000 rupees and going for a smaller room, because this particular combination, size of the product, size of the service, size of the room, going with a smaller size of room is worth enough to make a trade off with 2000 rupees of additional amount that I have to pay in case I go for a bigger room, right. Now, let us look at an example through which we can actually visualize the concept or metric of reservation price and percent good value. Let us posit a market consisting of 11 individuals with reservation price for a given product that is set at $30, $40, $50, $60, 70, 80 and so on up to $130. So, in this case we can see that maximum reservation price is $130 and minimum reservation price is set at $30. So, the person who is probably placing the lowest bid is ready to pay a maximum of $30 and a prior person who is ready to pay 130 rupees. He is the person who is ready to pay the maximum amount. So, maximum reservation price of the individual ready to pay the maximum is $130 and the lowest reservation amount is $30. The manufacturer of the product seeks to decide upon its price. What should be my price? If it is $30, then I will be able to sell the entire amount of my stock, right. All the 11 persons will purchase the product. Clearly, it might do better than to offer a single price. For now, however, let us assume the tailored prices are impractical, means we are not setting different prices for different individuals with different value addition. That can be one of the option in order to maximize the profitability of the organization, but for the sake of understanding of reservation price, let us try to understand that we need to set only one price, and the condition given is that the situation says that the variable cost to produce the product is $60 per unit. So, from this data point it is clear that if you are selling the product at $30, you are incurring loss. If you are selling the product at 40, you are incurring loss. If you are selling the product at 50, you are incurring loss. If you are selling the product at 60, then you are breaking even, and then above 60 you are getting some contribution margin. With this reservation prices, the manufacturer might expect to sell 11 units at $30 or less, 10 units at price greater than 30 but less than or equal to 40 and so on. It would make no sense, no sales at a unit price which is greater than $130. If the price is set at $130, then the company will be able to sell only 1 unit of the product. For convenience, we have assumed that the people buy at their reservation price. Anybody will be willing to buy a price below that reservation price, right. This assumption is consistent with the reservation price being the maximum of an individual that the individual is willing to pay. Now, let us illustrate this example with a table, that is this one. So, as we have said that variable cost associated with production is $60. So, now if the price is set at let us say $20, then I will be able to sell all the 11 units. So, what will be the total contribution? So, for each of the unit the variable cost is $60. So, for each unit sold I am losing in terms of contribution margin an amount of 20 minus 60, that is $40. So, for 11 units, 11 into 40, that is 440. So, total gross contribution from this business is 440. If it is set at $30, similarly the total contribution is minus 330. If it is for $40, minus 200. If it is for $50, minus 90. If it is 60, we are breaking even and it is 0. If it is 70, then it is $70. If it is 80, $120. If it is 90, $150. If it is 100, $160. If it is 110, $150 and so on, right. So, remember that we are considering that price of the product is an antecedent of quantity demanded. So, that is why you need to find out the right price so that the quantity demanded can contribute the highest amount of profit. So, in this case if I go by the numbers, which particular price point is giving me the highest contribution. The highest contribution across the data instances is 160 and that is given at a price point of $100. So, now if I have to optimize the price, I have to set the price of the product at $100, not 90, not 110. So, this is the optimum price. So, this optimum price is similar to, let us say, if we draw a demand curve, I mean law of demand and law of supply. If we draw the demand curve and supply curve, the point of equilibrium is the optimum price. So, here also we are actually identifying the point of equilibrium and which is $100, right. A table of quantities expected at each of several prices is often called a demand schedule. So, this particular table where we set the price and the corresponding demand, then it is called a demand schedule, or sometimes it is also called a demand curve. This particular example shows that one way to conceptualize a demand curve is as the accumulation of the individual reservation prices. Although it will be clearly difficult in practice to measure the individual reservation prices, the point here is simply to illustrate the use of reservation prices in pricing decisions. It is extremely difficult, right. We cannot ask each and every individual what is your reservation price. So, another way of doing it is that we can get the reservation price of a particular segment and based on that we decide on the optimum price. In this example, the optimal price, that is the price that maximizes the total contribution, is $100, that we have already seen in the table. This particular example also illustrates the concept of consumer surplus. What is consumer surplus? It is something like I am ready to pay 100 rupees, but I am getting the product at 80 rupees. Then I have a consumer surplus of 20 rupees. From my perspective, from the customer's perspective, it is a surplus, but from a company's perspective, it is an opportunity lost. Reservation price also sheds some light on the consumer surplus and the opportunity lost. At $100, the manufacturer sells 3 items at a price point below the consumer's reservation price. 4 persons are ready to pay $100. The person whose reservation price was 130, the person whose reservation price was 120, the person whose reservation price was 110 and the person whose reservation price was 100. So, for 3 persons we are selling the product at a price which is below their willingness to pay, right. So, the consumer with the reservation price 110 enjoys a surplus of $10, the consumer with reservation price 120, he enjoys a surplus of $20 and the consumer with reservation price of $130 enjoys a surplus of $30. So, what is that? What is the total surplus that is derived by the consumers is 30 plus 20 plus 10, that is 60. This $60 is an opportunity that is lost by the company. From a manufacturer perspective, the total consumer surplus is $60. It represents an opportunity for the increased contribution if it can find a way to capture this unclaimed value. Now, let us look into the third aspect of today's discussion, that is the linear demand. Linear demand assumes that quantity demanded is a linear function of set price. The slope is expected to be constant. The quantity price schedule formed by an accumulation of reservation prices can take a variety of shapes. When the distribution of the reservation price is uniform, when the reservation price are basically equally spaced, as in our example, the demand schedule will be of linear form. Each increment in price will reduce the quantity by an equal amount. So, this will represent a linear line or straight line. So, let us get into detail of this mathematical form of it. As the linear function is by far the most commonly used representation of demand, we provide a description of the function as it is relates to the distribution of the underlying reservation prices. So, what is the equation? What is the form of a linear line? It is always y equal to a plus bx, where a is your intercept and b is your slope. So, what does a represent? Basically, a represents the amount at which even if the x value is 0, the y value will be minimum value of y, even if the x value is 0. The a represents the slope, means rate at which the value of y changes with unit change in the value of x. So, it takes only 2 points to determine a straight line. Likewise, it takes only 2 parameters to write an equation for that. Generally, the equation is written is y equal to mx plus b, which I have already said. It can be a plus bx, or you can just put it as y equal to mx plus b, where m is the slope of the line and b is the intercept of the line. So, you can look at the left hand side of this slide. There is a diagram. So, on the x axis we have the price, and on the y axis we have the quantity demanded, right. So, we can put various point in this particular graph. So, the price, if you see the last point in the price axis, the last point is the maximum reservation price, right. So, reservation price is the maximum price an individual is willing to pay. So, if you set the reservation price, maximum reservation price, that is set by the individual who is ready to pay the highest amount, then you are going to get only one customer. There is one concept called the maximum reservation price, which is slightly higher than the reservation price of the person who is ready to pay the highest amount, right. Similarly, there is another concept which is the intercept of the y axis, that is maximum willingness to buy. So, this represents a hypothetical situation where if the price of the product is set at 0, then what is the maximum number of customers that are ready to purchase the product? This is a hypothetical situation. So, in a way it is a surrogate of the overall market size, right. So, these two metrics are important, these two price points are important to derive the quantity demanded at a given price if the function is considered to be a linear function. So, the quantity axis intercept can be viewed as a representation of the maximum willingness to buy. This is the total number of potential customers for a product. A firm can serve all these customers only at a price of 0. Assuming that each potential customer buys 1 unit, MWB, that is maximum willingness to buy, is the quantity sold when the price is set at 0. Formally, the price axis intercept can be viewed as the maximum reservation price. Basically, this MRP is a number slightly greater than the highest reservation price among all those willing to buy. If a firm prices its product at or above the MRP, no one is going to purchase the product. So, these two aspects, the two indices indicates the extreme cases. One, the price at which the demand will be 0, and the price at which everybody will buy the product. And everybody belonging to the market size will buy the product. So, let us formally look at this two constructs. One is maximum reservation price, it is the lowest price at which the quantity demanded equals to 0. Maximum willingness to buy, the quantity that customers will buy when the price of a product is set at 0. These two are artificial concept. Basically, in practical life it does not happen. You would not like to sell 0 products, neither you would like to sell the product at a price of 0. Now, we can devise an equation for the quantity demanded if the price of the product is known with respect to MWB and MRP. And the equation is something like this: Q equal to MWB, maximum willingness to buy, multiplied by 1 minus P by MRP, maximum reservation price. So, how this equation can be visualized is that quantity demanded if the price is 0. If the price of the product is 0, quantity demanded will be equal to that this one, maximum willingness to buy, right. All the customers belonging who have an intention to buy will buy it. Price is no more a concern. So, basically at 0 price, what will be the quantity demanded? It is MWB. If in this equation, if I put the value P value as 0, then it will become, quantity demanded will become MWB multiplied by 1, right. Similarly, if price is equal to MRP, maximum reservation price, as per our concept or concept, the quantity demanded should be 0. So, as per this equation, if P equal to MRP, so 1 minus MRP divided by MRP will give us a value of 0. So, total quantity demanded will be MWB multiplied by 0, that is 0. So, this establishes this equation. These two extreme cases establishes this equation. So, from now onwards, if we have this MWB value in place, if we have this price in place, if we have the MRP value in place, then we can easily calculate the quantity demanded at that particular given price point. Look at this example. Erin knows that the demand of her soft drink is a simple linear function of price. She can sell 10 units at a price of 0. When the price hits the $5, then the demand falls to 0. These are the two extreme cases given. How many units will Erin be able to sell if the price is set at $3? So, we can use the previous formula, right. So, quantity demanded MWB, maximum willingness to buy, into 1 minus P by MRP. So, maximum willingness to buy in this case is 10 multiplied by 1 minus the price is 3 divided by maximum reservation price, that is 5. So, 1 minus 3 by 5 will give us a value of 0.6, 0.6 multiplied by 10, it will give us a value of 4 units. So, 1 minus 0.6 is 0.4. So, for Erin's soft drink, the MRP, maximum reservation price is $5 and the MWB, maximum willingness to buy, is 10 units at a price of $3, 10 multiplied by 1 minus 3 divided by 5, that is 4 units, right. When the demand is linear, any 2 points on the price quantity demand function can be used to determine the MRP and MWB. Let us say we know that the line is this one, the relationship between quantity demanded and price is a straight line. If this is the assumption, then if any 2 points are given, if any 2 points of, let us say P1 and Q1 are given, P2 and Q2 are given, then we can definitely calculate what is the value of MWB and what is the value of MRP, right. So, if P1 and Q1 represent the price quantity point on the line and P2 and Q2 represent the second, then the following two equations can be used to calculate the MWB and MRP. Now, we will quickly deduce these two equations. So, let me write it. So, what is the equation for quantity? Because we are assuming that it is the function is a straight line. So, we know that the equation for a straight line is equal to, let us say Q equal to A, where A is the intercept, A equal to Bx or Bp, let me put it as P because our variable is price, fine. So, A equal to A plus Bp. Now, Q1 will be equal to A plus B P1. Q2 will be equal to A plus B P2, right. So, if I just do, let us say this is the equation number 1 and this is the equation number 2. So, what will this equation 2 minus 1 give me? Just a minute, okay. Equation 2 minus equation 1 will give me, sorry, just a minute, this is the normal equation. Let me put this as equation 1 and this as equation 2. So, 2 and 1 will give me Q2 minus Q1 equal to B multiplied by P2 minus P1, right. So, in a way I can derive that B equal to Q2 minus Q1 divided by P2 minus P1, right. So, B equal to Q2 minus Q1 divided by P2 minus P1. So, now if I put this equation, if I rewrite the equation Q1, then I can calculate the value of, because I have the value of B in place. So, I can calculate the value of A. So, let me again rewrite it. So, I am going to rewrite the previously written equation, right. So, Q1 equal to A plus B P1. So, from this I can write the value of A equal to Q1 minus B P1, or I can write Q1 minus what is the value of B, that is Q2 minus Q1 divided by P2 minus P1 multiplied by P1. So, what is A? A is the intercept of the line, and the intercept of the line represent the maximum willingness to buy. So, maximum willingness to buy equal to Q1 minus Q2 minus Q1 divided by P2 minus P1 multiplied by P1, right. So, we have deduced the first equation, this one, right. Now, we can also try to deduce the second equation from the same formula, right. So, let me start with deduction of the second equation. So, remember initially we deduced one equation which shows that Q equal to quantity demanded equal to maximum willingness to buy multiplied by 1 minus P divided by MRP, maximum reservation price. So, this it was written here in this particular slide. Okay. This is the equation we have written. So, now we will deduce the second equation from this MRP equal to P1 minus P2 minus P1 divided by Q2 minus Q1 multiplied by Q1. So, let us start to deduce it. So, what is Q? Q was given as MWB multiplied by 1 minus P divided by MRP, right. So, let us again assume the same data points, that is P1 Q1 and P2 Q2. So, what will be Q1? MWB 1 minus P1 divided by MRP. Similarly, Q2 will be MWB 1 minus P2 minus MRP. Now, again what we will do, we will take this one Q2 minus Q1 equal to, so I can take a common of MWB. So, it will be multiplied by, because from this to this, so it will be P1 minus MRP minus P2 minus MRP, right. So, basically what we can do, we can further deduce this equation, right. So, from here I can calculate, it will be MWB multiplied by P1 minus P2 divided by MRP. So, now I can calculate the MRP value from this equation. So, my MRP will be now MRP will be MWB multiplied by P1 minus P2, P1 minus P2 divided by Q2 minus Q1, fine. So, now I have already deduced the equation for MWB. So, what is MWB? That is Q1, it is here, right, Q1 minus Q2 minus Q1 divided by P2 minus P1 multiplied by P1. So, I can now put this equation as Q1 multiplied by P1 minus P2 divided by Q2 minus Q1 minus Q2 minus Q1 divided by P2 minus P1 multiplied by P1 into again P1 minus P2 divided by Q2 minus Q1. So, what ultimately I will get is that the value will be from this side, I will get a value of P1 minus P2 minus P1 divided by Q2 minus Q1 multiplied by Q1. So, both the equations are deduced, fine. So, this is how, given the values of A and B, slope and intercept, if we assume that it is a straight line, we can calculate what is the value of MWB and what is the value of MRP, maximum reservation price. Or on the other side, if you know the value of MWB and MRP, we can easily calculate the quantity demanded at a given price. So, this is all for today. I will see you in the next class. We will discuss regarding the elasticity of demand. Thank you.